Chapter 14 Equation of a Line. In class 9, chapter of graphs, you have learned lines for the given equations like 3x minus 2y equals 7, x equal 5, y plus 3 equal to 0, etc. Such equations which are of first degree in variable x and y or x alone or y alone are known as linear equations, and each equation always represents a straight line. These are examples of linear equations, and the graph of these linear equations are always straight line graph. Okay, now you always remember any point which satisfies the equation of a line lies on that line. Any point which satisfies the equation of a line lies on that line. Also, any point through which the line passes always satisfy the equation of the line. Let us do some problems to show that property. Exercise 14a, first one. Find which of the following points lie on the line x minus 2y plus 5 equal to 0. There are 6 points given. You can do the third one homework. We will discuss the fourth one now. One point is given, that is 5, 5 is a point. You have to find whether this point lie on the given line or not. How can we check this point 5, 5 is on this particular line? This is a linear equation, no? So the graph is always a straight line. So 5, 5 lies on this straight line or not? That is the question. How can we check whether 5, 5 lies on this line or not? Yes, we have to replace x equal to 5 and y as 5. Here x value and y value, this coordinate x coordinate and y coordinate. Same here. So we have to apply x is equal to 5 and y is equal to 5 in this equation. So we should get the right side as 0 here. Then the left hand side and right hand side are same. We can say yes, this point lies on the given line. Otherwise, no, it is not. Let us check this point. Let us apply the value x means 5. Let x equal to 5, y equal to 5. So 5 minus 2 into y. 5 plus 5. What is the value here? 5 minus 2 5s are 10 plus 5. 5 minus 10 minus 5 plus 5 equal to 0. Yes, which satisfies the equation, no? Yes. 5 5 satisfies the equation. Therefore, 5 5, the point 5 5 lies on the given line. This is the method. How can we check whether a point lies on the given line or not? Yes, you have to replace x value and y value, variables x and y, as 5 and 5 and check whether the answer on the right side is same. If yes, the point lies on the given line, otherwise not. Now let us do the fifth one. 0.2 minus 1.5. Same question itself, x minus 2y plus 5 equal to 0. Instead of x, we can replace 2 and minus 2 into y is minus 1.5 plus 5 equal to 0. That is 2 plus 3 plus 5. We have to check whether the answer is same or not. 2 plus 3 plus 5 is 10. It's not equal to 0. Here the value on the right side is 0, no? So it is not correct here. Therefore, no. 2 minus 1.5 does not lie on the given line. Understood the method? So do the sixth one homework. Don't forget to do the first one, sixth homework. Next type problem, question 3. Question 3 is a line 2x minus y by 3 equal to 7 passes through the point K6. Calculate the value of K. What is given in the question? This point K6 satisfies the equation of K6 satisfies the equation 2x minus y by 3 equal to 7. That is given in the question. So we can replace x as k and y is equal to 6. X equal to k, y equal to 6. That is 2 into k minus 6 by 3 equal 7. What is 6 by 3? 2. 2k equal to 7. Minus 2 changes to plus 2. That implies 2k equal to 9, k equal to 9 by 2. Or you can write it as 4.5. This is the value of k. Understood? This is the method to calculate the value of k. Question number 4, homework, sixth one. Does the line 3x minus 5y equal to 6 bisect the join of 5 minus 2 and minus 1, 2? Here we will get a line segment connecting these 2 points, no? And other line is 3x minus 5y equal to 6. They bisect each other or not? That is the question. Bisect means what? Yes, divide that given line equally, divided into 2 equal parts. Is that possible or not? That is the question. First, to bisect means we have to find the midpoint of the given line, no? This is the line joining these 2 points. So, how can we find the midpoint? Yes, you have learned in the previous lesson, that is x1 plus x2 by 2 and y1 plus y2 by 2 is the coordinate of midpoint. So, first of all, we have to find the midpoint by using these 2 points. And that midpoint satisfies this line or not. That is the method to solve this problem. That means whether the midpoint of this line segment passes through the line 3x minus 5y equal to 6. If yes, it bisects. Otherwise, no. Let us check. Midpoint of line joining 5 minus 2 and minus 1, 2. That's equal to 5 plus minus 1 by 2 and minus 2 plus 2 by 2. That is 4 by 2 and 0 by 2. What is 4 by 2? 2 and 0 by 2? 0. So 2, 0 is the midpoint. Whether this satisfies this equation or not. Let x equal to 2 and y equal to 0 in 3x minus 5y equal to 6. Implies 3 into 2 minus 5 into 0 equal to 6 or not, we have to verify. That implies 6 minus 0, that's equal to 6. Yes, 3x minus 5y equal to 6. Therefore, yes, 3x minus 5y equal to 6. This line bisects the join of 5 minus 2 and minus 1, 2. Bisect means we have to find out the midpoint of that line joining these 2 points, and that point whether which passes through or satisfies the given line, equation of the given line or not. If it is an yes, which is bisect the line join. Otherwise, no, it does not bisect. Understood the method? Okay, next one is 10th problem. Note down question number 8 as homework. Okay, now 10th question is, there is a line segment joining the points 5 minus 4 and 2, 2 is divided by the point Q in the ratio 1:2. Does the line x minus 2y equal to 0 contain the point Q? Actually, in this question, the point is not given. We have to find the point. How can we find the point? Have you learned that portion, section formula? Yes, by using that only we can find the point Q. Ratio is given, m1 is to m2 is 1:2 and x1, y1 is 5 minus 4 x2, y2 is 2 and 2. So we have to use the section formula to find q. Let us find out q. How can we find q? By using section formula? Yes, m1 x2 plus m2 x1 by m1 plus m2. This is x coordinate, and y coordinate is m1 y2 plus m2 y1 by m1 plus m2. Here you can see m1 is to m2 is 1 is to 2. So let us substitute. 1 into x2 is 2 plus 2 into x1 is 5 by 1 plus 2, and 1 into y2, that is 2, and m2, that is 2 into y1 minus 4 divided by 1 plus 2. That is 2 plus 10 by 3, 2 minus 8 by 3. That is 12 by 3 and minus 6 by 3. What is 12 by 3? 4, and minus 6 by 3 is minus 2. So these are the coordinates of the point Q. We found the point Q. Okay, Q is 4 minus 2. Now we are going to check in this line, that is x minus 2y equal to 0 contain Q. How can we check this? Yes, we have to substitute x as 4 and y as minus 2. Let x equal to 4 and y equal to minus 2. Substitute this value in the given equation. What is the value? 4 minus into minus plus 4. That is equal to 8. It's not equal to 0. 0 is given in the question now. In the condition it is given x minus 2y must be 0. But we got the value. What is the value we obtained? Yes, that is 8, which is not equal to 0. That's why we can write no. Q does not lie, or Q does not, the line does not contain Q. X minus 2y equal to 0. Okay, in this line we can't find the point Q. Understood? And similar type problem is question 9. Question 9 homework. Don't forget to do the problem as homework. Next topic is inclination of a line. The inclination of a line is the angle which the part of the line above x-axis makes with x-axis. This is x-axis and this is a line. What is this inclination? It is the angle between the line and the x-axis measured from x-axis. Here we can measure this in anti-clockwise direction. Let the angle, in general we use the term theta, letter theta to represent an angle. If measured in anti-clockwise direction, it is positive. Theta is positive. And if in this case you can see this is x-axis and this is the given line and here is the angle. So it is measured in, start with the x-axis. We start measurement from x-axis to the line. So this is in clockwise direction. So the value of angle is negative. Inclination of x-axis and every line parallel to it. Look at this line. Another line. A line parallel to x-axis. What is the inclination of this line L1? With respect to the x-axis? Yes, the inclination is 0 degree. And every line parallel to perpendicular to x-axis is, here you can see this is x-axis and perpendicular to x-axis. This is another line and it is perpendicular to x-axis. And what about the inclination? The inclination of y-axis and every line parallel to, or you can say in this way also, any line parallel to y-axis. This line is parallel to y-axis. Also it is perpendicular to x-axis. So what is the angle between the line and the x-axis? It is 90 degrees. So the inclination is 90 degree. Okay, remember these things. Positive inclination, negative inclination and a line parallel to y-axis. And also, what about the y-axis? Y-axis inclination is 90 degree. Every line parallel to y-axis also 90 degree. And x-axis, what about the inclination of x-axis? It's 0. And also every line parallel to x-axis also 0 degree. Understood? Now the next is slope or gradient. Next is slope or gradient. The slope of any inclined plane is the ratio between its vertical rise of the plane and its horizontal distance. For example, here is a slope. Slope of any inclined plane. So you can see this is an inclined plane. And what about the slope of this inclined plane? It is the ratio between its vertical rise. Can you mark the vertical rise? Yes. This is the horizontal distance. Horizontal distance, or you can horizontal distance. And what about this one? It's vertical height, no? Vertical rise. Vertical rise of a plane and its horizontal distance. The ratio between vertical rise and horizontal distance is called the slope of the inclined plane. This is an inclined plane. Okay, so you can write the ratio. Let the vertical rise be AB and horizontal distance be BC. Then how can we find the or write the ratio of vertical rise and horizontal distance AB by BC? And with respect to this angle, let it be theta. Its vertical rise by horizontal distance is same as perpendicular by base, no? Or opposite side by adjacent side? Yes. That is actually the value of tan theta. So, the slope of AZ is actually the tan value of theta. Slope of AC is the tan value of the inclination. Tan value of the inclination of the plane. That is AB by BC. Okay. So, how can we find the slope of a line? Slope of a line is equal to, slope is represented by using a small letter m. So, slope is equal to tan theta. That means tan value of the inclination. Inclination is the angle between its horizontal and that inclined plane. So, tan theta, tan value of inclination gives the slope of a plane. Now, what about the slope of a straight line? Yes, it's also same. Suppose this is a straight line and we have the angle theta here. So, how can we find the angle of this or slope of this line? Slope is equal to tan theta. Understood? So, slope of x-axis. Then can you say what is slope of x-axis? Slope of x-axis is tan 0 degree, because we know that inclination of x-axis with respect to x-axis 0 only. So, inclination or slope of x-axis is 0. And what about that of y-axis? It's tan 90, no? Slope of y-axis is tan 90. It's infinity. It's not defined. Okay, it's not defined. And slope of a line is positive if it makes acute angle in anti-clockwise direction. In this case, the slope is positive. And what about the other situation? That means if the inclination of the line is like this, yes, the theta is negative. So, we have the negative slope. Slope of a line is negative if it makes an obtuse angle in the anti-clockwise direction. Here you can see this is obtuse angle and this inclination we measure from this So this is negative theta. That's why slope will be negative. Okay. For example, if this angle is 45 degree, then what about the slope? Tan 45, that is 1. And suppose this angle is 45, but we measure it as, yes, minus 45 degree. Or we measure this as 135 degree. Okay. And this inclination of the line is tan of minus 45 degree. Minus 45 degree gives minus 1. Okay. Now let us find the slope of a straight line passing through two given fixed points. When 2 points on a line are given, how can you find the slope? Here it is the easiest one. That is, when an angle is given, very easy to find the slope. Take the tan value. Tan value of angle gives slope. Suppose the angle is not given, only 2 points on the line